welcome to our second technical seminar today. I'm Jana Torno, and I'm in Apple's Product Introduction Group. During the next 90 minutes, we will be broadcasting Apple networking products for IBM host connectivity live from Apple in Cupertino. On June 12th, Apple announced a whole family of products which would allow you to integrate the Macintosh into your IBM host environment. The family of products include both hardware, such as the Coax Twin-X card, the Token Ring card, and the Serial NuBus card, as well as software such as Mac APPC, Mac DFT, and CL1. During this seminar, we're going to begin with an overview of this entire family of products. Following the overview, we're going to go into more detail in each of the specific environments. We'll start with the Coax environment, then the Token Ring environment, then host development software, and finish with a section on CL1. You're going to have two opportunities in this seminar to call in with your questions. The first opportunity will be at the end of the IBM section, and the second opportunity will be at the end of the seminar. So write your questions down as you go along. All you'll need to do is call 408-974-9933, and our panel of experts will answer your questions. It's time now to introduce the first players in this seminar. First, we have Russ Winsper, the engineering manager for IBM Connectivity Products. Second is Dave Naj, the IBM Communications Product Marketing Manager. And third is Bill Brown, Manager of Communications Product Marketing. We're ready to begin the seminar now, and we're going to start with an overview of the entire family of products.
Our overall objective in providing SNA on the Macintosh platform is to apply the Macintosh intuitiveness, consistency, and extensibility to industry standard environments such as the IBM host world through SNA. So what we want to do is preserve the end user investment in understanding of applications, their understanding of the Macintosh interface, but layer beneath that IBM SNA standard communications. Our target for these communications products in SNA are SAA, or Systems Application Architecture, Common Communication Support. IBM has defined a series of 5 layers of communications functions, of which we implement virtually all in this product announcement. Our overall goal in implementing these tools underneath the Macintosh interface are to provide IS application developers, as well as commercial programmers, with the tools, protocols, and interfaces to add value on the Macintosh environment. The cards are all based on a common computing platform that we call the Macintosh coprocessor platform. Each of the 3 cards has in common a 68,000 microprocessor, half a megabyte of memory, ultimately up to 4 megabytes of memory on some of the cards. And its most critical element is a real-time multitasking operating system that allows us to run multiple protocols on the card. Now, the only difference in each of the cards is how they handle their I/O, whether that be Token Ring, high-speed serial communications, or the Coax Twin-X connections to the mid-range and mainframe systems are the parts of the card that vary. So in running these multiple simultaneous protocols, we're able to have, for example, in the Token Ring environment, simultaneous LAN access right alongside our host access. The first family of products built on this Macintosh coprocessor platform include the Apple Coax Twin-X card, which has as its I/O a Twin-X connector to go to the IBM 36, 38, and AS400, and it's got a coaxial connector for connection to the mainframe systems through a cluster controller such as a 3174 or a 3274. The software that runs on the Coax Twin-X card is called Mac DFT, and DFT is IBM's standard for multiple session support to an IBM host. It's called Distributed Function Terminal. We implement these multiple sessions as well as add Macintosh value. One of the most critical elements of the Coax Twin-X card, in my opinion, is the 3270 API that we provide to developers. The Mac DFT application, which provides terminal emulation windows, is fine, but in our goal of providing Macintosh consistency and Macintosh interface on the IBM host, we need a way for IS application programmers, as well as commercial developers, to use these SNA facilities, but not present the end user with an emulation window, a text-based window. So some of the tools that use this application programming interface include CL1, which you'll hear about later, the SQL-based connectivity language, Mac Workstation, also uses this application programming interface so that programmers can create Macintosh interfaces on the host. And then, of course, programmers can use this programming interface directly from C and Pascal languages. The next set of products deals with SDLC communications. In this particular case, we connect to an SNA network directly as a PU2O or a node type 2.1 connection, replacing, for example, a 3174 cluster controller. The product that we have in this case is the serial NB card. And this is the card with 4 high-speed serial ports on it that we layer Mac APPC, our implementation of LU62 and node type 2.1 protocols on it, as well as MAX25, which is our CCITT X25 software that you'll hear about later, also runs on this card. We've implemented this software to allow developers, either IS developers or commercial programmers, to create peer-to-peer applications that integrate AppleTalk into the SNA environment. Specifically, we can distribute these LU sessions out over a network through a non-dedicated server, or that directly connected machine itself can be the LU62 node. The final set of products deals with token ring communications. The card is called TokenTalk NB, and it's got the industry standard Texas Instruments 5-chip set on it for its I/O, and a variety of software. Starting with the local area network environment, we include with the TokenTalk NB card AppleTalk software, which we call TokenTalk, which essentially provides the customer with a 4 megabit per second token ring network. Everything else from the end user perspective is the same. It's just that it's running at 4 megabits per second. Often customers want to connect Macintosh systems to Token Ring and access files on MS-DOS machines. So also with the TokenTalk NB card, we include the SMB file transfer utility, which allows us to exchange files with MS-DOS systems running the PC LAN program, for example. Third parties will also use this card and the associated software to provide Macintosh client access into other environments, Novell being a good example of that, which they support today on Ethernet and LocalTalk and will in the future on Token Ring. For host access, we also have MacDFT. The identical application that I described for use on the coax card is used on the TokenTalk NB card as well. From the end user perspective, the only thing that's different is in the control panel when you configure it and select which card you're going to use. Everything else is identical. Also for host access, for the development of new distributed applications, we have Mac APPC. So APPC runs on the serial NB card as well as on the TokenTalk NB card. Let's take a closer look at how organizations can put these products to work. For Macintosh access to IBM mainframes, the key requirement is for 3270 terminal emulation and file transfer. To get us started on the solution to this problem, we've asked Morris Teradalski, Apple Vice President of Customer Satisfaction, to elaborate on the needs of large organizations in this area.
What I've seen in talking to many of our customers is that they love the Macintosh. They want to bring it into their enterprise. They want to put it in front of all their users. But the problem that they have to deal with is the fact that they have a very diverse set of requirements in their networking, and they have a tremendous investment in existing equipment and in particular in existing wiring schemes that they use. This really requires us to make sure that we allow our customers to leverage that existing investments, such as IBM mainframes, 3090, running systems such as MVS, VM, System 38, AS400s. And it also requires for us to allow them to leverage all their existing cabling. Our customers have a tremendous investment in coaxial cables, cables that run throughout their company, throughout all their buildings, and into almost every office in their enterprise. And so what we need to provide is the ability for them to take those coax cables and unplug them from the 3270 that they're using today and plug them into the Macintosh, and then allow them to leverage both of those systems.
The needs outlined by Morris were key factors in the design of Apple's SNA product family. Our goal was to enable Macintosh users to connect to mainframes using existing wiring and networking equipment for access to information and resources. Maybe the first thing we should do is to give a quick description of just how Apple's new connectivity products will fit in this environment. This diagram shows an SNA SDLC network with a System 370, front-end processor, cluster controllers, including IBM PCs and actual 3270 terminals. We now add a Macintosh 2 with a coax TwinX card and MacDFT software installed. We'll talk later about the 3270 API and how it can be used by Macintosh programmers to create Macintosh applications that use these facilities. What I'd like to do now is talk more specifically about functionality and implementation issues. The first topic is how to install and configure the coax TwinX card and MacDFT.
The installation of the Apple coax TwinX card and MacDFT is very straightforward. You simply install the card in any of the new bus slots in your machine, and then drag the system files off of the distribution disk into your system folder, and then restart the Macintosh. You then use the control panel and select the 3270 icon under the control panel, and use it to select the type of configuration that you're going to be using. We have a video that we're going to run right now that will demonstrate the installation and configuration process.
On the desktop, we have a folder that contains the files we need that were loaded from a floppy disk for the MacDFT installation. Select the 3 configuration files, drag them into the system folder as you would with any normal Macintosh application, close the folder, and then restart the system. Once we've loaded the MacDFT software and restarted the system, we can now configure 3270 sessions by opening the control panel and selecting the 3270 control panel device that was installed. Once selected, a number of entry fields appears. Along the top, a radio button indicates which of the Macintosh 2 slots your coax TwinX card is installed in. Below, we can select from among 3 connection alternatives: CUT, DFT under an SNA environment, and DFT in a non-SNA environment. In this case, we'll select DFT and close the control panel. Russ, what do the CUT, DFT, and non-SNA DFT choices in the control panel represent?
Well, as you saw in the video there are 3 choices. CUT stands for Control Unit Terminal, which is probably the most common type of terminal that's out there. It's a single session, basically a dumb terminal. Relies on all its intelligence from the cluster controller itself. Under DFT, which stands for Distributed Function Terminal, it's a more intelligent terminal, as the name suggests. It actually has SNA protocols and supports up to 5 sessions concurrently. The third choice was DFT non-SNA. That, of course, is a non-SNA device. It's locally attached to the front end. And again, it contains 5 sessions, but does not contain any SNA protocols. The way you would use those basically depends on the type of control unit and the port that you're attached to. And your site administrator would be the best person to ask for specific information there.
Thanks. Now that we have the card and software installed, the next step is to configure 1 or more 3270 sessions. Bill, how is this done?
Well, the first step really is to use the standard Macintosh model and double-click on the MacDFT application. Once the application opens up, you can use the Configure menu to select things like the number of sessions you want to support, the names of the sessions, what type of screen formats you're going to use, and a number of other options. We also have a video that demonstrates the configuration of MacDFT.
With our control panel settings completed, we're now ready to launch the MacDFT application and configure a number of 3270 host sessions. We see a menu bar appear across the top that includes a configure option. We select this menu item and choose the terminal option, and we'll be presented with a dialog box that will allow us to select from among the 5 possible 3270 sessions for us to configure, in this case number 2. We can rename the session. In this case, we'll rename it to VM, because we'll be logging on to our VM host with this configuration. We'll close the dialog box Go back to the configuration menu and configure a second session. Again, choosing the terminal option, selecting session number 3 from the dialog box and renaming this to MVS so we can access our MVS environment. We can also choose the type of session. In this particular case, we'll leave it at display model 2, but we could also choose models 3, 4, or 5 for the different screen formats in the 3270 environment. In this particular case, we would also like this window to open at launch when we start MacDFT, so we select the checkbox and then click OK, and we have our sessions configured. Once we've configured the number and type of 3270 sessions under MacDFT, once we launch that document, we automatically get those windows opened. In this case, we have 5 terminal sessions, and with the window option in the menu bar, we can either tile the windows or stack the windows front to back. Before moving on to implementation issues, we have several demonstrations on tape that will show you how the basic terminal emulation functions as well as the value added by Macintosh works. Operating under MultiFinder, MacDFT also supports the Macintosh standard copy and paste functions. In this particular case, we have a 3270 session open, and we'll use the mouse to select some textual information, copy it to the Macintosh clipboard, go to the Microsoft Word application, and simply paste the data into the document. If our 3270 window contained tabular information, such as rows and columns of numbers, we can also use the copy function to select that information and paste it into a spreadsheet, such as Microsoft Excel, while retaining the format of the numbers. In addition to copy and paste between Macintosh windows, we'll talk later about file transfer to and from MVS systems based on IBM standard file transfer mechanisms. The following demonstrations illustrate several more key features of MacDFT. MacDFT also includes a keystroke record and playback function. It's implemented in the Auto Key menu selection. To create a new series of keystrokes, we select New from the Auto Key menu, and we get a box where we can enter information, or a box that information is recorded into once we're actually performing the keystrokes. In this case, we'll key in a logon sequence so that we can log on to profs using our existing username and password, and we'll close the box. We can now assign a name to this series of keystrokes. In this particular case, we'll name it Profs Logon so that we can recall it later. We'll also select the box that allows us to include it in the Auto Key menu for automatic selection. We then close the dialog box, and we'll go up to the Auto Key menu, and we can see that the Profs Logon sequence that we just created was automatically added to the Auto Key menu. For users that prefer to have on-screen function keys, we also have a menu selection called Keypad that allows us to choose from a variety of function keys. In this particular case, we have a large keypad that we can move around the screen, open and close at will. In the case of our Profs Logon, we may want to create a new keypad that's smaller and more specific to our purposes. In this particular case, we'll make the box smaller. We only want to say a dozen or so keys. We'll select from among the standard set of keys and assign them to a position in the new keypad. You see along the right-hand side, we have our Auto Key sequence that we created earlier listed. We simply select it, go back to our new keypad, point to the destination and click it with the mouse. And we see that our Auto Key function is assigned to that key on the new keypad. We can then close the dialog box now that our keypad is created, assign it a name so that it appears in the keypad menu so we can invoke it in the future, and just click OK. Close the box and go back to the keypad menu and see that our new Profs keypad, customized for our Profs Logon, is added. We can tear it off and reposition it around the screen at will. MacDFT also allows us to configure our keyboard to match an actual 3278 terminal. We select the keyboard option from the Configure menu and are presented with this dialog box. Along the top, it shows an actual 3278 keyboard with the function keys Along the bottom, we have a corresponding Macintosh keyboard. In this particular case, we have an extended keyboard installed with the function keys across the top. In this case, we want to assign the PF12 key to the PF12 key on our Macintosh extended keyboard, and we simply select and drag the keypad icon onto the destination. In this particular case, we'll also select the Enter key from the 3278 keyboard and assign it to our return key, since that's what we're familiar with hitting. Keys that are grayed out are keys that cannot be changed. Every other key on the keyboard can be remapped. So far, we've seen how to connect a Macintosh for access to host-based information and services in the Macintosh way. Let's move into some specifics. Russ, how does the Macintosh appear to the 3174 or 3274 cluster controller, and does the cluster controller configuration need to be changed to accommodate the Macintosh?
Basically, the Mac appears as a standard 3278, 3279 terminal. The user can unplug from the back of an IBM device and plug it into the Macintosh, and it should still continue. The design goal was basically to have no impact whatsoever on the cluster controller, the front end, or the host. We are using the National Semiconductor's 8344 coax chip, which has become virtually an industry standard. It's being used by DEC, HP, Lee Data, and Memorex Telex.
How can files be transferred between the Macintosh and mainframe from within MacDFT?
We support the IBM standard IND dollar file, and under CUT we use a presentation space based approach, which is using the session that is currently connected. Under DFT we use D0 structured fields, which uses one of the 5 sessions concurrently so that you can be transferring files in background. We support basically TSO and CMS at the moment.
The file transfer dialog box has 3 options for file transfer: text, binary, and Mac binary. Under what conditions should each one of them be used?
The text option should be used to transfer or exchange documents with your mainframe. For example, you can use Xedit, the mainframe editor, to create a document and download it to the Mac, where you might use Mac Write on it. Mac binary really is used for transfers between Macintoshes. For example, this might be using the mainframe as a backup device for your local hard disk, or to use the mainframe as an exchange point with another Macintosh that it was in a different location. The binary option really is what you would classify for everything else. So if you were trying to, say, exchange a document, say an MS Word document that you prepared on the Macintosh with MS Word on a PC, you could exchange it through the host using binary.
What are the options for printing from within MacDFT sessions?
MacDFT supports all of the standard IBM print functions in a 3270 environment. There's local copy and host-initiated print to a cluster controller attached printer, standard 3287 capabilities. It also includes what we call local copy to an AppleTalk connected printer, so we can print to a laser writer, for example. And it, in essence, is the same as a screen copy, if you would, of the active screen session.
And my last question is about the TwinX component of the card. I know it has 2 connectors on it. Is 5250 terminal emulation software available to connect to a System 36, 38, or AS400? And one additional part of this is, can both 3270 and 5250 sessions be active simultaneously?
When we announced the products in January, KMW Systems also announced their TwinX AppLink, which is their 5250 emulation software that runs on the Apple TwinX coax card. So there are 5250 solutions available for the card. One, I guess, problem is that you can't run both simultaneously. Because of the design of the National 8344, you can only run one protocol at a time, either coax or TwinX.
Okay. Let's take one more look at the diagram to see how the Macintosh with the coax TwinX card and MacDFT software fits into an existing SNA network. Here we have the SNA network with the Macintosh added, running the MacDFT software and the coax TwinX card installed. And then we see the system connected and accessing information on the host computer. We've now seen how these products fit into the SNA environment that Morris described earlier, incorporating industry-standard connectivity with Macintosh integration and value added. Before moving on to a discussion of token ring connectivity for access to IBM systems, let's go back to Janet for a review of how one key Apple customer uses Macintosh to increase its productivity and competitive advantage.
Let's take a look at how customers like Codex can benefit from integrating Macintoshes into their customer environments.
In the past, the IS organization used to be a central function operating on large mainframes, and we really serviced only the home office. With this network now, we're able to distribute that processing power all over the world to every one of our sites, so they can now tap into that information to do their jobs better and more efficiently.
A sales rep time is money, both to the company and to him. Therefore, the Macintosh really stood out as far as a quick learning curve, a quick way to get him interested, make it fun for him to be on the network, and something we could offer some immediate advantages in. The IBM mainframe is perhaps the biggest benefit to the users of being online on the AppleTalk network. Sales reps can call up and get very timely information on the status of their orders. Obviously, that's a question a customer is always asking. Where is my order? What point of the chain is it in? And now the sales rep has easy access to that information.
The transfer of files between the Apple and the IBM environments is really transparent to our users. They can transfer files from one application to another easily, seamlessly.
The Mac can access the host perhaps easier than a 3270 terminal in some ways. It's a simple double click on a file and you're on the host. And they can exchange files with the file server, and so people on Macs can read IBM files and vice versa. We can now copy and paste between applications on the IBM mainframe and the Macintosh. Basically, we've been able to integrate all the different technologies we have in the company in one environment.
In fact, our strategy is that the single footprint for a terminal on the desk would be the Macintosh. And the communications capability allows us to have access to all the other Macintoshes or IBM PCs in the network, as well as to the IBM mainframe or any other mini computer that we have in the network. So truly, that user has on his desk the capability to access any information in the company.
The futures that I've seen certainly all point to even a closer connectivity with the IBM mainframes, more tools to allow the interchange of data between the Mac and the IBM mainframe. It leverages the investment we've made in the various technologies.
Having the single network with seamless communication among all our computers on a worldwide basis, I think is truly a competitive advantage to us, and not all companies today have that capability.
Now, of course, in addition to coax cabling, a lot of facilities have token ring installed. And joining our panel now to talk about how you can integrate your Macintosh into the token ring environment is Buzz Dean. Now, who you might ask is Buzz Dean? Well, we asked that very same question of our man on the street.
We've asked many questions on the street, but the most important one is, who is Buzz Dean?
Buzz Dean, that's me.
He does cartoons for the New York Times. He's the head of the Chicago Bears. I don't know. I don't. Dizzy Dean's son?
He's the mayor of New York.
Did you believe? I don't believe you. You just picked this name out of a hat. That's my husband. He's not famous or anything. It's a cute name, though, you have to admit.
Well, actually, all of those people are wrong. Buzz Dean is actually Apple's Manager of Communications Product Development, and he's now joining our panel to talk about Macintosh in the token ring environment. Buzz?
Thanks for joining us, Buzz. So far, we've outlined how to connect a Macintosh to an SNA SDLC environment as a 3270 terminal. Let's go back to Morris and see what else people are asking for.
Another very important requirement that our customers have, here again, leveraging existing investment, is the need for us to support their local area networks that they have already put in place, connecting their MS-DOS machines, whether they're from IBM, Compaq, or other vendors, connection on that same local area network using token ring to the mainframe systems. And they would like to have a Macintosh connect via the token ring protocols and allow the Macintosh then to access all of the information that might be kept on a mainframe, on one of their MS-DOS systems, or on a server that happens to reside within their enterprise. So that they, again, can leverage the power of the Macintosh into this network.
The key question here is how can we provide access to both LAN and host-based services via Token Ring? Let's answer the question first, then get into the details. This diagram shows a System 370 connected to a Token Ring network along with MS-DOS and PS2 systems. A Macintosh 2 family system is added to the network with a TokenTalk NB card running both AppleTalk LAN and SNA host services. Let's get down to the details of how the Macintosh fits into the Token Ring environment for access to IBM 3270-based applications. First, how is MacDFT configured to run over TokenTalk NB?
The configuration of MacDFT in a Token Ring environment is very similar to the coax environment. The principal difference really is the fact that you're shifting from a point-to-point connection to a local area network environment. And this requires you to put some information in terms of addressing on the ring. Okay. We have a video that we're about to run that will show you how you configure it and what the various fields mean. First thing to do in configuring MacDFT from Token Ring is to select the control panel under the Apple menu. When the control panel comes up, you then select the 3270 icon. This will bring up a configuration dialog for MacDFT. You notice that the radio button in slot 2 is highlighted, which is displaying the coax connection configuration. Because MacDFT supports multiple cards, slot 3 is also highlighted. Slot 3 in this case happens to be a Token Ring card. If we had an SDLC card in, it would also show up. By clicking on slot 3, you see the Token Ring configuration fields. The first field is the burned-in address. You cannot alter this field. This is the address that is burned into the ROM on the card. The second field, the current address, is editable. And you have to edit this field so that the values that your host expects for your address are entered. This is a 12-digit number that is located in the NCP gen of your host. The next field is the remote address. The remote address is the address on the ring of the device you're trying to talk to. In this case, it would be either a 3174, a 3725, or 3745. This is also a 12-digit number and is supplied by your systems administrator. The final value to be entered is your XID. This is an 8-digit number that is contained in the NCP gen for your mainframe. Since the key to configuring MacDFT on a Token Ring are entering the correct addresses, it might be useful to spend some time on finding out where they come from. We have a number of graphics that really illustrate the source of these. This particular configuration happens to be the Token Ring in Buzz Dean's lab, which really is it's a standard Token Ring environment running through 3745. The first field I'd like to point out is the ID block field. The ID block field represents the first 3 digits of the XID. And remember, the video said that the XID was an 8-digit number. The second part of that number is the ID num. And you get your 8-digit XID number by concatenating these two together. The local address, the address of your device on the ring, is derived from the last 12 digits of the dial number in the NCP gen. The final value, really the address of the device or gateway that you're trying to talk to, is usually stored in the NCP gen for that particular device. Fortunately, in that case, you don't really have to divine what it means. It's a very clear 12-digit number.
Buzz, how does a Macintosh running MacDFT over TokenTalk NB appear to the 3174 cluster controller? And the second part is the 3174 the only host connection path that's supported?
Well, like an MS-DOS or PS2 machine, we appear to be a PU2. Not only do we support the 3174 connections, but we also support the 9370, 3745 direct attach, 3725 direct attach, and both flavors of 3174, remote and local.
Well, if MacDFT is running on a PU2 stack, doesn't that imply support for up to 32 sessions?
Actually, the architecture describes 254. but in our current implementation, we've stuck with the DFT standard of 5. When we distribute sessions, 3270 sessions out across AppleTalk, then we'll lift that restriction.
What types of cabling can TokenTalk NB card be used with?
Right now, shielded, unshielded, otherwise known as Type 1 and Type 2, and that goes through a DB9 connector. We also support the Type 3, which is telephone twisted pair. But with that, because of the difference in the plastics between our machines and others, you use a short adapter cable available from third parties, Nevada Western, for example.
The final product we want to talk about in this segment is the SMB file transfer utility. This software allows the Macintosh user on a token ring to exchange files with MS-DOS systems that are running the PC LAN program. Let's take a look at a demo that shows the utility in action. The SMB file transfer utility that's packaged with the TokenTalk NB card can be used to exchange files with MS-DOS systems. In this particular case, on the right-hand side, we have a series of MS-DOS volumes that reside over the token ring on the PC LAN program. On the left-hand side, we have the Macintosh volumes where we would like to copy the data to. Once we copy the information, we would also like to perform a conversion. In this particular case, we would like to go from Lotus to Excel using the standard format. So we go back to the MS-DOS window, find the appropriate file. In this particular case, we'll have some sales information. Click Translate, and it will copy the information and translate it at once. This dialog box shows the progress while it's copying the information and performing the translation from Lotus to Excel. So now the Macintosh has access to 3270-based mainframe applications, as well as files on MS-DOS systems over the token ring. Let's take one more look at how it all fits together. Here we have the token ring network with the IBM mainframe attached MS-DOS machines. And we add a Macintosh system, the SMB file transfer software, as well as MacDFT running over token ring. So far, we've seen how Macintosh users can access applications, files, and services on a range of IBM systems. We need to check in with Morris one more time to make sure we're covering everything.
Aside from the requirement for our customers to connect the systems physically, to be able to attach the Macintosh to existing networks, whether they're coax or twinax or whether they're token ring, there's also a very, very important need for the developers within their organizations, people who write the applications for their systems, to get the necessary tools to allow them to integrate and extend the Macintosh applications and capabilities with their existing applications. And it's very, very important for them to be able to, again, understand their existing environment so that we don't force them to have to learn all new methods and learn all new languages and capabilities, that it becomes a natural extension of what they already know and what they already can deal with. Then they can leverage the true power of the Macintosh into their existing environments.
The products we'll cover in this segment are targeted toward the application developer. First, we'll talk about Mac APP PC, which is Apple's implementation of SNA LU62 and Node Type 2.1 protocols. Then we'll focus on the Apple 3270 API, a programming interface that allows developers to build Macintosh applications that access IBM mainframes running VM or MVS. The first network diagram here shows an SNA network, again with traditional connections, cluster controllers, token ring networks. And then we add Macintosh to the systems running MacDFT, SMB file transfer, API, Mac APP PC. The key question here is how can our customers put Macintosh to work so that it presents the user with more than a text-based 3270 window? Let's start with a description of the products. Buzz, as one of the architects of Mac APP PC, can you tell us what Mac APP PC is?
Mac APP PC is Apple's implementation of the LU62 and PU 2.1 architectures. What we've done is we've implemented it in a toolkit form. So it's accessible from C, Pascal, 68,000 assembler, and a particularly neat function is the fact that you can use what we call hyper APPC, which allows you to execute any of the LU62 verbs from a HyperCard HyperTalk script. Since LU62 was defined by IBM, it's been adopted by a number of other computer manufacturers as diverse from Cray to Apollo. And what it's become is kind of a lingua franca for cooperative processing among different machine types, as well as within the same family of machines. We've done this in a fairly interesting way. We've used a server-client architecture, and I'll get onto that with the next slide. Now, probably most important, anytime you're talking about a protocol that's shared among many different architectures, you want to be able to prove that you can interoperate. And the interoperability, in our case, was proven by the fact that we were the first non-IBM customer to complete the LU62 interoperability test service. Now, here's a diagram of what the implementation looks like. Using either the NuBus serial card or the Token Talk card, you place that in any Macintosh 2 family computer in your AppleTalk network. That's where your protocol processing is done. It's not a dedicated Mac 2. You can continue using it just as a normal personal computer, and yet it provides the functionality out to the various clients on the AppleTalk network. What this accomplishes is, for the client, it uses very, very little of the system memory to do protocol processing and leaves it available for your complete transaction program.
Bill, can you tell us about the Apple 3270 API and show how programmers can take advantage of the Macintosh for accessing new and existing 3270 applications?
The Apple 3270 API is a high-level programmatic interface that enables developers to add the Macintosh look and feel to existing mainframe-based applications. And in this case, high-level means it's accessible via C, Pascal, even HyperCard, so that even your average programmer can add those capabilities.
Is the Apple 3270 API similar in any way to IBM's high-level language API?
The Apple 3270 API is functionally very similar to IBM's Halapi. Although there are only 24 commands versus Halapi's 43, all the functions necessary to maintain a session with a 3270 environment exist. This graphic shows that the mapping between some of the key commands that exist. So it's send keys in the Apple environment, it's send keys without the underscore in the Halapi environment. So it's very parallel to the functions of the IBM Halapi.
So in general, when should Mac APPC be used versus the 3270 API?
Well, there's actually a spectrum that includes Mac Workstation in that discussion. If what you want to do is put a Mac look and feel on an existing 3270 application without changing host code, you can do that with the 3270 API. If you'd like to change the host a little bit or possibly write a new application, then Mac Workstation on the host and Mac Workstation on the Mac would be another approach. And if you want to do true cooperative processing where you have distributed data, possibly across multiple machine types, then the LU62 protocol implemented through Mac APPC would be the way to go. Want to add anything, Bill?
I think the easy rule is that if you're doing new applications and you really want to take advantage of the power of your Macintosh, not really use it as a dumb terminal, then you use Mac APPC. If you're trying to put a Macintosh front end on an existing application, then you would use the Apple 3270 API. So it's new versus existing is really the key split.
That takes us through making a connection as a Macintosh to a 3270 terminal over coax, token ring, as well as accessing files on token ring-based MS-DOS systems. We've also covered the key developer tools that allow Macintosh programmers to create customized applications that use these SNA facilities. Before moving on to questions and answers, here's a quick summary of the products we've covered and their planned availability dates. Coax Twin X card along with its corresponding software, which will be bundled with the card, available in the control unit terminal version in July, and we'll have a free upgrade to the DFT functionality around the fall of this year. The Apple 3270 API is currently available through the Apple Programmers and Developers Association and through Apple Software Licensing. TokenTalk NB card will be available next month in July. It will not support the full 3270 DFT functionality until October, when we ship the DFT functionality. The API will also be supported on the TokenTalk NB card. Mac APPC 1.1, which will run on the serial NB card as well as TokenTalk NB, will be available in about the same time frame in October of this year. And the SMB file transfer, the utility will ship with the TokenTalk NB card in the box. And finally, the serial NB card, which will run Mac APPC 1.1, will be available in the fall, in October. And you'll hear later about Max 25, which also supports the serial NB card. Now we have time for some of your questions about these products. We'll try to give you the best answers we can, then we'll move on to information about CL1.
Great. So get on the phone, call 408-974-9933, and we'll take your questions. While we're waiting for the first question to come in, we're going to take a look at what some of the questions our man on the street has had.
There's a lot of acronyms out there, like the FBI, the CIA, and a lot of us know the IRS. Well, what about MCP?
Monsters, crazy, police.
That's right.
Is that it?
SAA, sampling active animals.
SNA.
Snails of North America.
MCP.
McChicken patty. Great, we have our first call. It's from Russ in Milwaukee. What's your question, Russ?
In the October time frame, when you talked about DFT being available, is that when I'm going to be able to distribute 3270 sessions across Token Ring and Ethernet? There's a follow-up.
Unfortunately, no, it's not. We're only going to be supporting 5 sessions off the terminal that's connected to the ring in the October time frame. A future release, we'll be looking at distributing those 5 sessions.
Can I add something to that? I think that the model, that if you're interested in how it's going to be implemented, if you look at what we've done in the Mac APPC arena, where we already distribute sessions over the Ring environment or the local talk environment, and also in our X25 product, which, since it hasn't been discussed yet, you haven't seen. But those are the models that we're really following. So we will use Apple Talk as a distribution mechanism for all of those services.
Russ, did you say you had a follow-up question?
Yes, and the follow-up session is, will there be a mechanism to distribute AS400 sessions as well?
I'll take that. Yes, both for 6.2 and in the future 5250 connections.
Okay, great. We have Chris from Menlo Park instead. Go ahead, Chris. What's your question?
Hi, Janet. I have a question about support for GDDM graphics in the IBM terminal products.
Okay.
If and when those might become available.
Great.
At this particular point, we have not addressed GDDM. We're going to be looking at that in the future.
Can I add something to that? I think the priorities that we're following for additions to the 3270 product are, number one is distributed sessions, because we realize that's very important to our customers. Number two is what we really call host-based printing or host-initiated printing to Apple laser writers. If you remember during the presentation, I mentioned the fact that we supported host-initiated printing, but only to 3287s that are attached to the cluster controller. Access to the laser writer was for local copy, but in the future we want to be able to have the host use one of the DFT sessions and direct printing right to a laser writer that's connected via Apple Talk.
Okay, go ahead, Mark. What's your question?
Yes, you mentioned that the Apple TwinX coax card supports the TwinX protocol, but could you clarify how to apply 5250 and 5251 terminal emulation, on the System 38?
Okay, the card supports the TwinX connector out of the back of the card. Using KMW's Twin Access AppLink product, which again uses our card. Merely install that software in your machine and connect it into the TwinX cabling system in your environment that's connected to the 38, and you have standard 5250 style emulation on the Macintosh.
Thank you.
Good. Okay, our next call is from Glenn in Chicago. What's your question, Glenn?
Yes. Will Mac DFT support a local printer as a host addressable printer? That'll be like a 3287. Can I route print out to a laser writer?
I think I addressed the current printing capabilities are to use any printer that's attached to your cluster controller as you normally do in a 3270 environment. The capabilities of the laser writer, or the ability to use the laser writer, right now are limited to local copies, or local copy, what's really known as local copy, since the control unit is not involved. Okay. In the future, we will be supporting the ability to print to a laser writer directly from the host, but we're not, currently envisioning doing anything else in the 3287 environment. I don't know if that answers your question.
That's pretty close.
Okay.
Can I ask two more questions?
Sure, go ahead.
Does it support the two-page monitor?
Does Mac DFT support the two-page monitor?
Yes.
Yes, it does. It supports a two-page monitor. It supports our all of the monitors. In fact, it supports multiple monitors, and I can see of situations where you might want to put multiple monitor cards in your Macintosh and then put multiple monitors up and have a full window into each of the sessions.
Tile the DFT sessions across multiple monitors.
Right.
Terrific.
And you said you had one more question?
Yes, last question. You mentioned support for TSO and CMS. What about CICS?
File transfer.
Unfortunately, at this point, we're not supporting the CICS file transfer. We'll, again, be looking at that in a future release.
Let's be real clear. It's just the file transfer to CICS that's not currently supported. Using it as a terminal to connect to CICS is fully supported, and it works great.
Okay, does that answer your questions, Glenn?
Yes, thank you.
Great, thank you. Okay, I think we have Jim from Cupertino on the line again. Let's try one more time. Go ahead, Jim.
Okay, well, I've seen a demo of HyperCard and your APPC software with it.
Yes.
Can you tell me a little bit more detail how that works?
Sure. What we've done is we've written some X commands that, as you probably know, are extensions to the HyperTalk language. Then, in HyperTalk, you can write what amounts to an LU62 verb. The X command executes the translation from HyperTalk into the native APPC verb call, which goes through a driver in your system folder and then on to the card for processing. How's that?
Okay, great.
Can I add one other thing to that? Just like we've done with HyperCard APPC, where if there is an exposed or accessible programmatic interface in one of the products, we have a general policy of providing a stack of X commands that allow you access to those capabilities from HyperCard. And exactly what we've done in the Mac APPC environment will be followed in, for example, the Mac DFT environment. It'll be followed in the TCP IP environment.
Great. We have another call now from Dick in Menlo Park. Go ahead, Dick.
Hi.
Hi.
My question is, how will these products support the Mac SEs and the Mac Pluses in my environment?
I'll handle
I have a second question also.
Okay, stay on the line then.
Dick, we're particularly proud of the fact that we're doing a good job of supporting the CPUs that are not, quote, card capable or NuBus card capable. Bill just spoke of the fact that we are distributing capability out over AppleTalk. So if you have a Macintosh CPU that's connectable through AppleTalk, which is virtually all of them, then the function is provided for the non-card machines by a NuBus capable CPU, a Mac 2 family CPU, somewhere in your network. That includes spanning bridges, You can see across bridges and get the capability that way. Is that clear?
Clear, Buzz. My second question is, what's the fish do in your box?
If you saw the June 12th announcements, one of the features we had was Man with a Fish. And this is just a reminder that we're going to continue to enhance Man with a Fish.
That's release 2.0, though.
Yeah,
This is the 2.0 fish.
Okay.
Can I add one other thing to that particular question? I think one of the things that we're doing is we're following a client-server model in all of the work that we're doing, so that we can concentrate the services in a Mac 2 or 2X or 2CX, a new bus-based machine on the network, and then use the built-in networking capabilities of AppleTalk to provide those services to other machines on the network. And that's something we're following across the entire product line.
Great.
Thank you.
That's all the questions that we have time for in this segment. Keep your questions, though, because we're going to have another Q&A at the end of this seminar. And I just want to add one more thing to that last question, and that is that there are also third-party cards. On June 12th, when we announced our token ring card, H3 Systems announced a token ring card for the SC30. So keep in mind that there are third-party alternatives in addition to the cards that Apple has announced. Now, I think we've seen during that first session that there are certainly a lot of advantages to using the Macintosh instead of a dumb terminal for accessing mainframe applications. And in addition, there are a lot of reasons for trying to access host databases from the Macintosh. But in the past, we've had a lot of problems with that for a variety of reasons.